Hey, Science 10. This is Chemistry B, Lesson 6, Predicting States and Reactions. So in your notes package, it's actually just one page of notes, so this lesson will be short, but then the assignment will be quite a bit longer. It's kind of tying together basically everything from Chem A and what we've been looking at so far in Chem B. So predicting products, balancing equations. So it, it doesn't look that long. I think it's only 9-ish questions, but there's a lot that you need to do in each question. So writing the equation, writing the formulas for it, making sure that your formulas make sense. So that's kind of back to Chem A stuff. And then balancing it out, predicting the products and stuff like that. So let me know if you run into any stumbling blocks with that. So today's lesson is just predicting states. So once you've predicted the product of something, which we did in the last lesson, now you need to think about what state will it be in. So we indicate the states of compounds using brackets directly after the compound. So H2O with a little L beside it, that's water. So again, we know that's water. That's not dihydrogen monoxide. That's water. It's one of your memorized molecular. So water, and again, that L indicates that we're talking about a liquid. So we use L for liquid, S for solid, G for gas. You've seen before, especially when we're talking about acids and bases, another state that we can have is aqueous as well. So aqueous would kind of technically be a liquid, but it's actually dissolved in water. So a lot of our reactions will take place in the aqueous state, where it's not saying that liquid that you have is 100% whatever compound it is. It's saying that it's dissolved in water, again, in order to create those ions within solution. So our rules for predicting states, if it's an element, so if it's something on its own, it's not in a compound, we see this with kind of our single replacement reactions, or yeah, single replacements, formations, decomposition reactions. We'll see things that are just elements on their own. So you get your states of the elements directly off the periodic table. So you need to be looking in the periodic table, and kind of on the left-hand side, right near the top, it says legend for elements. And if the box that they're in the periodic table is white, it's a solid. If it's black, it's a liquid. And if it's gray, it's a gas. So in your periodic table, you can see the two that are liquids, again at room temperature, are mercury and bromine. The ones that are gases are all over on the right-hand side there. Um, so all of your noble gases, as well as chlorine, fluorine, hydrogen, oxygen, and nitrogen. So those are all gases at room temperature. So those ones, again, if it's just an element on its own, we know that we're going to be talking about using our periodic table. So here we have, it says, what are the states for the following? So H2, remember hydrogen when it's on its own is found diatomically. Um, it's one of our polyatomic elements. Again, that's in your chart there. So on the right-hand page of your periodic table, just above the periodic table, it says polyatomic elements. There it says hydrogen is H2. So looking in the chart, hydrogen, again, it's found in two spots. It is H plus or H minus. We haven't really talked about why, but that's more of a acid-base thing a little bit later in chemistry. But hydrogen is a gas. So the state for hydrogen is a gas. Au, that's gold. So looking in the periodic table for gold, it's atomic number 79. So have a search around for that. Gold is a solid at room temperature. Bromine, again, another one of our diatomic elements. Um, so when it's on its own, it's found diatomically as Br2. Bromine is a liquid at room temperature, so it's a liquid. And as we said, mercury is as well. So these are the only two that will be liquid at room temperature. Keep in mind that you can change this by changing the temperature, right? I could take iron and heat it up really hot and I could make it a liquid, but we talk about standard temperature and pressure. So standard temperature is like 25 degrees Celsius. Um, so this is saying at 25 degrees Celsius, what state would it be? So molecular compounds. So as it says there, it says lots of this is from experience and from the commons chart. So when we looked at your the ones that you memorized, we talked about things that you need to know and you need to have an idea. So solids, ones that are solids, something like sugar, we know, again, this is glucose, but sugars we know are going to be solids. Wax, so if it says it's wax and it gives you the chemical formula, so C25H52, you know that wax is going to be a solid at room temperature, but you can heat it up and make it into a liquid. Gases, if you know it's a gas at room temperature. So these ones are kind of just think about it if you don't have a way. So what is carbon dioxide at room temperature? Well, if you breathe out really aggressively, you know that it's a gas. Oxygen at room temperature, again, you've seen oxygen canisters. Um, it's a gas as well. Carbon monoxide, we've talked about that. That's what's coming out of the furnace with incomplete combustion. Um, and so those are gases as well. Other things that you should know, so methane is a gas, that's natural gas that goes into your furnace for heating your home. Ammonia, sorry, I'm flipping around here in my book. Ammonia is a gas as well. And C2H6, that would be ethane. Ethane is a gas as well. So you should just kind of know those ones. And liquids, you know if it's a liquid. So if we ever just say water, we're talking about liquid water. We know we can get to water that's ice and water that's a vapor, but we would tell you something like that. So we would say if it was solid water, again, that's ice. Or if we wanted to talk about water as a gas, we would call it water vapor. Molecular compounds can be aqueous. So if we tell you something is sugar water, so again, C6H12O6, if it's just on its own, it's solid, but if we say it's sugar water, we know that we've dissolved it into water, so it would be aqueous as well. So that's elements, molecular compounds, ionic compounds. Ionic compounds are all solids at room temperature. So that one's pretty easy. But of course there's exceptions. When a substance is identified as molten, then we're talking about the liquid form of it. So if something is molten, then it is a liquid. So molten sodium chloride is table salt that we've heated up. So molten, if you think of molten rock or something, lava. Sodium chloride molten would be NaCl as a liquid. So it's just heated to a higher temperature that it can become a liquid. If a substance is listed as aqueous in solution or dissolved in water, then again we use AQ as our state. Most single replacement and double replacement reactions take place in water, so most of the compounds will be listed as aqueous. But what you need to do, this is kind of back to CB2, if the reaction is occurring in solution and you are predicting states for products, so you'll have information, probably most likely your reactants are aqueous, but now we need to see if the products are aqueous as well, or if we would get that formation of a precipitate. We talked about that before as evidence of chemical change. Precipitate is when you mix two liquids together or two somethings together and a solid forms out of that. So you need to use your solubility chart. And so that would take us back to, again, lesson CB2, we talked about solubility. So if I had something like one of the products that came out of it was, I don't know, let's just use sodium chloride. We knew sodium chloride, it was some sort of reaction that we are mixing two things. So sodium nitrate, let's do this. Sodium nitrate and calcium chloride, CaCl2, produces, again, this is an example of a double replacement reaction. So we know that sodium forms a positive ion, so it's going to end up with the negative ion of chloride there, and calcium forms a 2 positive ion, so it will end up with nitrate. So we were probably told in the question, we have solutions, so both of these are aqueous. Now we need to figure out the states of these. So did it form a solid precipitate at all, or were they both aqueous? So back to our solubility chart here. So solubility chart, we can do sodium chloride first. So we see chlorine as an ion here. So looking, sodium is not in this part, so it needs to be here. So we would have aqueous, because again, if it's in that one, it's very soluble or aqueous. So we would have aqueous sodium chloride, and then nitrate is right here. So again, it's not these three, so it's in this part, so this would also be aqueous. And so that's what you need to do. You need to use your solubility chart to figure out whether or not it's going to be aqueous or if it's going to be soluble. Sorry, it's going to be solid because it's insoluble. They're very slightly soluble. So there we go. Oops, what have I done? So again, what you're going to need to do for that lesson, I'm just going to open it up quick on my desktop. For CB6, it's a process, but you can do it. We have all of these steps already. So what you need to do is think about what's happening. So the first step in production of sulfuric acid, uh-oh, I've lost my pen capabilities. I can only highlight. So the first step in the production of sulfuric acid is to burn sulfur to produce sulfur dioxide. Maybe I'll kind of go through part of this in here. Oh, okay, now I gotta go back to pen. So maybe we'll do this first one part of the way together and you can finish it up. So sulfuric acid. So we want to produce sulfuric acid. And so the first step is, oh, sorry, burns, oh, this one's a toughie. I was kind of reading it wrong. So burn sulfur. I don't know why I went pH there, to produce sulfur dioxide. So we know when we talked about this previously, when we're talking about a combustion reaction that involves burning, we actually need to burn it in the presence of oxygen. I'm going to go back to F. This pH thing is not working for me. So sulfur plus oxygen produces sulfur dioxide. So from here, so this is giving me kind of my word equation. So sulfur is one of our polyatomic elements. When it's on its own, it's going to be S8. Oxygen is diatomic. So O2 to produce sulfur dioxide. So sulfur dioxide. So I'll kind of stop here so you can finish up the questions. From here, you need to balance it and predict predict the states of the products. Actually, predict the states of all. So you can see what you need to do for each of these questions. You need to take it from a sentence. You need to write it kind of into a word equation potentially, then write it into a chemical equation. Again, all of your compounds need to be right. Then you need to balance it, and then you need to predict the states of all of them. So these questions are going to be quite complex. It'll take me a bit of work to mark this one, so make sure you write neatly and you give yourself space to do all of those steps. But in the end, I want to see a balanced equation with states with a nice little box around it or something like that. So hopefully that works out. Again, fire me an email if you need some help and support on that, and we will chat with you guys soon.